The question belongs to the section topology from a Gate 2025, and this question is a MSQ. So it is a MSQ question. But yeah, so this question says, let X be an uncountable set. Let the topology on X be defined by declaring a subset U which is containing a X to be a open if X complement of U is either empty, finite, or countable, and the empty set is a open. Then which of the following is true? So this is nothing but we call it a co-countable topology. Remember, co-countable topology is always T1 topology, and आई एज्यूम कि आप सब लोगों को ये पता होगा कि कंपैक्ट सबसेट क्या है और क्लोज्ड सबसेट क्या है. क्लोज्ड के बारे में हम डिस्कस करेंगे. और पहला, फर्स्ट ऑप्शन इज normally it is a correct कि everyone knows that the every compact subset of X is a closed, but चूंकि ये MSQ है, so there is another option, so we will check it now. Now come to the question. So what is a closed mean in a topology? So A is closed set if A complement is open. So A complement is open. If we have a some what we call it an example, and we have a set say Y that is 1 2 3 4, and here is a topology of Y. So there is a lots of topology. Let us bring this topology here, 1 and Y. So this is a topology. Now phi and the Y is a open and closed itself, but what about 1? What about 2 and 3? Is 2 3 closed? 2 3 is closed. Yes, it is closed because 2 3 complement 2 3 ka complement, which is 1, and that belongs to the topology, means it is 1 open. So now is 1 and 2 is 2 a closed set? No, it is not. Why? Because 2 complement is 1 and 3, that does not belong to the topology. तो इसका मतलब ये है कि जब भी कोई भी सेट, कोई भी एलिमेंट टोपोलॉजी को बिलोंग नहीं कर रहा है, उसका कंप्लीमेंट टोपोलॉजी को बिलोंग नहीं कर रहा है, वो क्लोज्ड होता है. सो कम टू द क्वेश्चन. सो क्वेश्चन सेज दैट फर्स्ट ऑप्शन इज करेक्ट. सो हमने पहले ही देखा कि एवरी कंपैक्ट सेट इज ए क्लोज्ड. आई एज्यूम कि आप सब लोगों को कंपैक्ट सेट के बारे में पता है, क्योंकि मैं ये वीडियो स्मॉल बना रहा हूँ, तो इसमें ये सारी चीजें डिफाइन करना थोड़ी बहुत मुश्किल ही होगी, बट आई एम ट्राइंग माई बेस्ट. सो एवरी कंपैक्ट सबसेट ऑफ एक्स इज ए क्लोज्ड. इज एवरी क्लोज्ड सबसेट ऑफ एक्स इज कंपैक्ट? नो. कैसे? अगर मेरे पास x होगा q is closed. Why q is closed in x? Because x minus q is uncountable. So when it is a uncountable, that means it doesn't belong here. It is q is closed, that will be the open. If that is a open, when we say it is a finite, or that means, so q is a closed in this topology, but q is not compact. सबको पता है q compact नहीं होगा, क्योंकि every finite subcover, it doesn't have a finite subcover. बट सबसे इंपॉर्टेंट यहाँ पे क्या है? क्या? So option 2 is not correct. X is a T1 and X is a T2. For the T2, I will prove it for the T2 and then you will assume it for. So claim X is T2. That means it is Hausdorff space. So what is the definition of Hausdorff? We have the two open setters U and V are the open setters such that X belongs to U and Y belongs to V. Then U intersection V is phi. These are the open setters. So these are the disjoint open setters. Now, agar X is a T2 space, therefore there also exists say U and V वहां भी एग्जिस्ट होगी, तो हम क्या कहेंगे x माइनस यू जब ये ओपन होंगे तो हम क्या करेंगे x माइनस यू x माइनस v इज काउंटेबल. जब ओपन है दैट मीन्स ये काउंटेबल होंगे बाय x u यूनियन x माइनस v. सो ये यहाँ पे यूनियन है. नाउ ये क्या होगा आपको पता ही होगा कि जब it will become x minus u intersection v by De Morgan's law. De Morgan's law. So when it becomes this, and this is countable. This is countable. This is also countable. That means union of countable. So this is countable. Now come to this. So we have x u intersection v is countable. What does that mean? U intersection v is open. Now question is it a empty or it is not empty? Now question is it a empty or it is not empty? If this is empty, then x is a T2. But if it is not empty, then x is not a T2. So assume that it is empty. Assume that it is empty. So what it become? X minus u intersection v. If it is empty, x is uncountable. It is in the question, x is uncountable. That means it becomes uncountable. But we got that it is countable. So that means it is always non-empty. So when it is always non-empty, that means it never be a Hausdorff. It never be a Hausdorff. And how it becomes it? How it becomes a T1 now? So it's once again a simple. But remember for the always that co-finite and co-countable topologies is always T1 topology. So now, so if we have a singleton setters are, so it is not. So singleton subsetters are closed, yes, क्योंकि अगर आपके पास कोई भी singleton subset है in X that belongs to the X, is it closed? Yes, it is closed because X minus X is uncountable. It is not countable. So this is a one logic. There's another logic, but yeah, always remember X is a T1 space. I hope you have understood it. Thank you.